Okay, so in this video, I'm basically just going to show you how mathematical induction basically works. So suppose, let's start simple reading with a geometric sequence there. So now we basically know that this thing is decreasing. So now we want to prove that using mathematical induction, really. So what we're going to start with, we're just going to start with the base case problem. So let's say here, just basically that n is equal or greater than 1. So with the base case, basically, then you just have a1, evaluate a1, you basically get half. And then if you evaluate a2, then you basically get that a2 is basically 1 over 4. And this technically shows you that a2 is probably, should be less than 1 over 4, it's less than half. So a2 is probably less than, it's basically less than a1. So then you have something like this. So then this basically shows that the base case is true. So now what we're going to do is we're going to assume that ak plus 1 is less than ak for some k greater or equals to 1. So now using this assumption, this yields by assumption. Now, okay, what we basically want is to prove that ak plus 2 should be less than ak plus 1. So from assumption, by assumption, we know that ak plus 1 is less than ak, which basically means that 1 over 2 to the k plus 1 is less than 1 over 2 to the k. So notice that if you multiply both sides by half, what happens if you multiply both sides by half? Then you just basically get half. 2k plus 1 less than 1 over 2 by 1 over 2 to the k. Then 2 by this one will basically add a 1 to the exponents. Then you have k plus 2. This will be less than half by 1 over 2 to the k, which will be this. And this one is basically just ak plus 1. Okay, should be less than sign there. Then this one will be ak plus 2. So basically then you prove that ak plus 2 is less than ak plus 1 from the assumption right there. So therefore we can then conclude by induction ak an is basically greater than an plus 1 for all n greater than 1, greater or equals to 1. So that would be basically how we prove that this thing is decreasing using induction. Okay, so then let's try a new problem now. Okay, so suppose now we have a sequence that's defined, and let's say a1 is 2 and an plus 1 is equals to 1 over 3 minus an. So we want to show by induction that this is basically a decreasing sequence. So then notice that we have a1. Remember, you're going to start with the base case. The base case, notice that a1 is 2, it's provided, and a2 will basically be equals to 1 over 3 a1. a2 will be 1 over 3 minus a1. And a1 is 2, so if you plug in 2 here, you basically get 1 over 3 minus 2, which is 1. 1 over 1 is 1. So a2 is 1, which is basically less than a1. So now we want to prove, we're going to, okay, so we know that the base case is true. So now we're going to assume that ak plus 1 is less than ak for some k greater or equals to 1. Then what we want to do is to prove that ak plus 2 is less than ak plus 1. So we can start off from our assumption there. By assumption, we know that ak plus 1 is less than ak. So then if we have a negative ak plus 1, basically what I'm trying to do is obtain something like this. So if I have a negative ak plus 1, whenever you multiply with the negative, the inequality sign must change, and then you have negative ak. Then add 3 on both sides, then you basically have 3 minus ak plus 1 this will be greater than 3 minus ak. And then if you reciprocate both sides, then the inequality sign must change again. So then you have 1 over 3 minus ak plus 1. This will be less than 1 over 3 minus ak. But now look here. If this was n, then you have n plus 1. But now you have a k. So that basically means that this will basically be ak plus 1. ak plus 1. And then here, since you have a k plus 1, then that technically means you'll have a plus 1 there. And then it shows that that will be ak plus 2. So then we proved what we wanted to prove. Then from then you're just going to conclude to end your proof. Therefore, by induction, an is less than, an is greater than an plus 1 for all n greater or equals to 1. So that will be how we do that thing.